Hello, welcome to Hawk Math. Today we're going to be solving the following problem. Now at first it looks really confusing and the notation might be slightly different from what you're used to, so I'm going to go over that really quickly. So you have the limit as n goes to infinity of the integral on the range from 0 to 1 to the nth power of x sub 1 plus x sub 1, x sub 2 squared, and so on, dx to the nth power. Now what this means is that we're basically taking n integrals where each x sub n ranges from 0 to 1, and we're taking the limit as the number of variables goes to infinity. Now this sounds really confusing and you really have no idea where to start. So in order to do this, most problems that go to infinity, you don't know where to start. The best solution is to try to find a pattern. So let's start off easy. Let's start with the integral from 0 to 1 of x dx. That's assuming there's only one variable. So then this will just give us 1/2 x squared evaluated from 0 to 1, which equals 1/2. Okay, so now let's do this part right here. That would be the integral from 0 to 1, and then we have another integral for the other variable. So we have another integral from 0 to 1. Now we have an x, and I'm going to make this other variable, x sub 2, I'm going to set it equal to y so it's easier to tell what's going on. So we have y squared, and then we have dy dx. So now let's solve this. Now in order to solve this, let's start with integrating by y. So we have the integral from 0 to 1 of x 1/3 xy cubed from 0 to 1 dx, which equals the integral from 0 to 1 of bringing a 1 here, that's going to give us a 1, so we have a 1/3 x dx. Now that integral is going to become a 1/6 x squared evaluated from 0 to 1, which equals 1/6. Okay, so I immediately already see a pattern here. We had a 1/2 right here, and then because of the 0 to 1, this x kind of went away. And then over here, we had a 1/3 times 1/2, and then the x went away again. All the variables went away. And that gives us 1/6. So what I'm starting to see is I'm thinking that it's going to be factorials, because this is 1/3 factorial, this is 1/2 factorial. But I'm going to keep going one more term and see if that pattern holds. And if that pattern holds, I'm fairly confident that's going to hold for everything. So I'm going to erase this just so I have more room. And let's set this so that we don't remember it's 1/6. Okay, so now let's do one more term and then see if that pattern holds. So the integral from 0 to 1, the integral from 0 to 1, integral from 0 to 1 of, now we have x y squared z cubed dz dy dx. Okay, so now in order to solve the same thing, showing step by step, so integral from 0 to 1, 0 to 1. Now we have an x 1/4 x y squared z to the 4th, integral value from 0 to 1, dy dx. Now we plug in, I'm not going to solve this all the way out on the board, but you can check. If you plug in the 1, that z is going to go away basically, so you can ignore this. Then we'll have the integral of this. And now this 2 will become a 1/3, and it will give us a 1/4 times 1/3, and then when we have to integrate the x, we get a 1/2. So indeed, it looks like this is the pattern. So this is going to equal 1/4 times 1/3 times 1/2, which equals 1/24. And so the pattern is holding its factorials. So we can now look at this. We wanted the sum of all of these. So in order to take the sum of all those, we really just want 1/2 plus 1/6 plus 1/24 plus so on. Now I'm going to clean up the board so that you can get a better look at what's going on. Okay, now how do we solve this series? Well, when you see that it's factorials in the denominator, you should think of the series for e to the x. We know that the sum from n equals 0 to infinity of x to the n over n factorial is equal to e to the x. So what does this mean? Well, if we expand this out, this is equal to plugging in 0, we get x anything 0 powers 1, so 1 over 1. Then plugging in 1, we have a plus x over 1 plus x squared over 2 plus x cubed over 6 plus x to the 4th over 24, and so on, is equal to e to the x. So how can we employ this right here? Well, we see that we have very similar denominators, 2, 6, 24, and so on. So, and we see that the numerator is always 1. So I'm going to try plugging in 1 into the x and see what happens. So we have an e to the first power is equal to 1, and then plus another 1, plus 1/2, plus 1/6, plus 1/24, and so on. But we don't want the initial two 1s, so let's subtract those to the other side. So you get 1/2 plus 1/6 plus 1/24, and so on, is equal to e minus 2. And that's our final answer. So this problem wasn't too bad once we broke down the notation and we found a pattern, but I really like it because it's interesting and different. So thank you for watching. I really hope you enjoyed the video. Please like and subscribe if you want to see more, and please feel free to leave any comments or suggestions down below.